Starting out Chapter 9, Lesson 9-1, this entire chapter is going to be all about area and how we find the area of different polygons. So getting into a lot more of what we think of geometry. But to start off with Chapter 1, we always need to kind of do an intro lesson, which will then set the stage for the rest of it. So I can state the area postulate. We are going to use that postulate to then later on apply it to different polygons. But first off, what I want you to write down is I want you to write down the definition. So the area of a polygon is the measure of the region bounded by it. And so if you look off to the left side here, we have our polygon that just has our line segments that are connected. Obviously, it is a closed polygon. There are no opens to it. But the area of it is this blue space. It's the area within it, which you've learned from pre-algebra. But again, it's just kind of a higher level of thinking that it's actually the area of this figure that's bounded. Second definition, by a polygonal region, what we mean is basically the union of a polygon and its interior, which is kind of what I already explained. It's just we have our polygon shape. A polygon is just the line segment itself, and then the space within it is its interior. First one, the area postulate. So again, from our learning target, this is going to be important, that every polygonal region has a positive number called its area. So every single region that we talk about, where it's the polygon and its interior, has a positive number of space that takes up that's called area, such that the first step to the area postulate is that congruent triangles have equal area or are equal to each other. So again, just because we're starting to move into higher level polygons with quadrilaterals and everything else, we're still going to be going off of our basis with triangles. So yes, as we've joked around in class, we are going to be continuing to use our triangle proofs later on as we go through. So the first one is congruent triangles have equal areas, meaning if I take this polygon and I split it up, all these triangles, if I say that they are congruent to each other, then I'm going to say, I can also say that they have equal area. And then the second piece to the area postulate is that the area of a polygonal region is equal to the sum of the areas of its non-overlapping parts. So a lot of the times, we're not going to have shapes that are necessarily perfect, that are going to necessarily be equal. And so what you could do to figure out this, if I asked you to basically figure out the area of this shape right here, there's a couple ways in which you can do it. One of the ways is basically saying if I took my pencil and I drew a line separating this figure into a quadrilateral up here and a quadrilateral down here, making them both rectangles, you'd be able to say that if I found the area of this one up here and found the area of this long one on the bottom, and added them together, the sum of the areas would then equal the entire thing. So as I said there, I guess I got a little ahead of myself, so I should have clicked to the next one. So if I said that ABCD is a parallelogram, just a reference for later on for homework, just so you know, you don't need to write any of this down. But if I know that this is a parallelogram based off of what I've done in previous chapters, I know that its opposite sides are going to be equal to each other, and I know that if I drew a line here and divided the parallelogram into to two pieces here, that this also would be equal. Now, looking at the triangles themselves, if I asked you, okay, so what triangle congruency proof would I be able to quote to say that triangle ADC is congruent to CBA, you would be able to say, hopefully, that it's the SSS, because all the sides are equal in this case. And because I know that I have congruent triangles, looking back at that area postulate, I know that I have that the two triangles there are going to be equal to each other. Now, also, using the second piece of it, I also would then be able to say that if I took the area of the bottom triangle here on the left, and I took the area of the top triangle on the right, and I added them together, that would be equal to the area. So this is alpha, sometimes noted as the area of ABCD. The entire thing, if I added these two triangles up, would be equal to that entire thing there. And last but not least, what I'd like you to do for for homework technically, but before we get to class, is I want you to find the area of this shape right here. There's multiple ways in which to do it. Who's to say that one way is the correct way of doing it? But again, take your time on it, and I want to hopefully be able to get the answer. And if you can figure out one way, see if you can figure it out possibly a different way as well. So we'll see you next class period. Thanks.